Hello guys, Mr. G here, and we are going to be making another video for projectile motion grade 12. This time we're going to be talking about velocity versus time graphs. Last time we did some questions on graphs of position versus time. Now we're going to explain the velocity versus time. There are some videos, if you go to the channel and you look carefully, there's already videos on this one, so maybe you can watch it, and there is things I will not mention here because the time is different and I forget stuff. Okay, so you can compare the videos and watch them and so on. So let's start by talking about velocity versus times graph. First of all, remember velocity is a vector quantity, and therefore it has magnitude and direction. Velocity is a vector with magnitude and direction, and you need to have in mind that the velocity, we have a motion that is going either down or up in our work, so you have to be considering what direction you take as positive and what direction you take as negative. So in this case here, we're going to divide the page in two parts. So the first thing we're going to see is in one side of the page we're going to look all the time up as positive, and in the other side of the page down as positive, and we are going to look at different situations when the object is moving up and when the object is moving down, and then last we are going to see when the object is moving down and bounces. And two obvious at the end, you will have to combine all the graphs in questions and so on. Okay, so let's start with object that is moving up. So we're going to be looking at this situation where an object is being thrown up from the ground. It does not really matter from where it was thrown up. You need to know that eventually the object will be at the maximum height, and at that point the velocity of the object is going to be equal to 0. Now I want you to notice something. The velocity is going to be throughout the motion going to increase, but it's always going to be pointing up. So velocity will always be pointing up, and therefore it doesn't matter if you take down or positive or up as positive, always the velocity will be pointing up. So if we say up is positive, the velocity will always be positive. Okay, so if we say up is positive, the velocity will be positive. If we say down is positive, the velocity will be a negative, and this is something for you to remember all the time. Okay, so it doesn't matter the situation, but always if you say up is positive and the object is moving up, then the velocity will be positive throughout the whole motion or graph, and the other way around. So let's draw the two axes quickly. Alright, so here is the axis. Now before we start drawing the graph, let's notice something here important. In both cases, the object is always going to start with certain velocity which is different than 0. It is going to start with an initial velocity. As the object moves up, the velocity will decrease as moving up until the maximum height, which is 0. So you're starting with a number that is different than 0. Now, this one here, which is up positive, is going to start from a positive direction because it is moving up. So this one here could be the initial velocity. Remember, not values needed in this explanation. Okay, and then here, because we say down is positive and the object is moving up, the velocity will be on the negative y-axis. There is the initial velocity. Now, what does the object do? What does the velocity do? Velocity decreases. So this one must come moving straight line down all the way up until a point. So you can see there, for instance, that is just before reaching the maximum height. So up until the maximum height, at the maximum height, the velocity is going to be equal to 0. So here, there is the time to reach the maximum height. And if you go to the y-axis right here, that will be the final velocity or velocity at maximum height. That is the velocity at its maximum height, which is equal to 0. If you go to down as positive, you're starting with negative because down is positive and the object is moving up. The velocity is pointing up. So the same story is going to be moving in this direction up until it reaches the x-axis. Now I want you to be careful because people think or learners think that when the graph is in this direction up, it means the object moving up. This has nothing to do with the object moving. It has to do with the direction of the velocity. Remember all these negative numbers here, it doesn't mean other thing but direction. So here we're starting from a number that could be any number different than 0 and obviously greater than 0, and eventually this is the time it took to reach the maximum height. And if you go all the way to the y-axis, this one here is the velocity the object has at the maximum height, which is equal to 0. There we go. So that is the velocity at its maximum height. So note that shape, the shape of these two graphs, please. It's not that difficult, okay? Now, let's see the same situation, but when the object is now being dropped, okay? Now the object is going to be dropped. All right, so now here the object is being dropped. Remember, it's dropped, it does not necessarily need to be dropped. It could be thrown down. We did already a question like that in the previous video, where the object is being thrown down, but the only difference then is that the initial velocity is not going to be 0. Okay, now this object is going to be dropped. So note that the velocity is going to be pointing down all the time. So here on the left, just for you to remember, we said up is positive. And because the velocity is pointing down, it's going to be negative. Now, it's going to start from 0 because the initial velocity is 0. There is the 0. The initial velocity is 0 right here. So it's going to increase up to certain point. So if we draw a line, it must be a straight line that is going all the way up until there. So there we can see that this one here is going to be the time to reach the maximum height. Let's make a dotted line there. And this one here will be the velocity that the object have at the ground. Okay, not the maximum height, the time to reach the ground. So this is the time t, and this one here will be the velocity. This one here will be the velocity at ground level. That is the velocity at the ground level, but the velocity increases. Now, if we say up is positive, which is the right side here, down is positive, the object is moving down all the way, and therefore the velocity will start from 0 because it's been dropped. If it was not dropped, then we'll start from any other number, which is not 0. Okay, but this case is dropped. So the velocity is going to increase all the way up until it reaches the ground level, which is going to be different than 0. So here you will have the time, I'm going to write time to either reach the ground or time before reaching the ground, and here is the velocity which the ball reach the ground. There we go, velocity reaching the ground. So here you see the first two scenarios and the difference between object is being thrown up and object is being dropped, how the graph would look. So let's do now one where the object is being thrown up and it's go all the way up and down. So the whole graph, how it will look. So here we are. We are going to have an object that moves up and down. Okay, up positive. Remember on the left, all the left graph is up positive, and all the way on the right is down as positive. Okay, so now if the object is moving up first, all you have to go is here and look how it looks when the object is moving up, which is the first scenario. So the object is going to move up. Therefore, the first part is going to be starting from the initial velocity here all the way straight down to the x-axis. Now, this is the total time, or the time taken. That one there is the time taken to reach the maximum height at that point, but the object doesn't stop at the maximum height. The object continues moving up until the ground, but now why it went to the negative side? Because it changed direction. It's moving all the way up, we say up is positive, but then eventually the object moves down, and down is negative in this situation. So this is the final velocity of the entire motion, which is the velocity reach the ground, at which the ball reached the ground, which is drawn there. Okay, so it's a straight line. So I'm sorry if there is a small curve. It's not so easy to write here. This must be in a straight line. Now here is when we say down as positive. The object is going to be negative because it's thrown up. So the initial velocity is going to be negative in this case because the object was thrown up all the way to the x-axis. The x-axis, guys, is going to be like when you change the direction of the velocity, okay? It's going to be that point. This one here is the time to reach the maximum height, but the object continues moving all the way up until the ground. So here is going to be the final velocity, or velocity just reaching the ground. And we're going to see one last scenario when the ball is going to bounce. Now that one is the one that could be very, very tricky. So in this case, the object is going to bounce. It's going to go all the way from there to the ground, and it's going to bounce all the way 2 times. So let's do that graph quickly. That could be a little bit more tricky. Let's keep on this side here, let's keep the up as positive, and here we're going to keep down as positive. Remember, I cannot do all the possible graphs. This is for you to get an idea and be able to understand graphs, okay? But I cannot do all the possible graphs there are. So let's look at this one real fast. Now let's first analyze here. The object is being dropped in this case, okay? Object is being dropped, so the velocity is going to be all the time downward up until it reaches the ground, okay? So that is important, because we say up is positive, the velocity is going to be negative because it's pointing down. Okay, so let's look carefully here. We have the object that is being dropped, so the velocity is going to be pointing down all the time, okay? Velocity is going to be pointing all the time down and starting from 0. So because we said that up is positive and the velocity is going to be pointing down and we're starting from 0, this is the initial velocity. The velocity is going to be negative all the way up until it reaches the ground at some time. So this is the velocity of that object when it reaches the ground for the first time. I'm going to call that one T1. So here it's going to be T1 for everyone. Okay, so that velocity is going to be somewhere there negatively, because we say up is positive and the velocity is going to be down all the time. Now, what does the velocity do when it reaches the ground? Well, let's say, what does the object do when it reaches the ground? It bounces, so it starts moving up. So the direction of the velocity changes immediately to up. So the velocity straight is going to move all the way. The direction is going to be now positive direction or positive velocity. So that is the initial velocity of the first bounce. Okay, and the object, what does it? Move all the way up until the maximum height of the first bounce, which is the x-axis, which is there. So let's call that one here. There we go. We're going to call this one times 2, which is h maximum height. Right? So this is the time at the maximum height is T2. What does the object do? Well, it go all the way down and therefore it changes direction. That is why it's going all the way to the negative side up until some point there. This one here is the final velocity, or velocity with which the ball reaches the ground for the first time. Now again, and this can really be a little bit tricky, eh? Here we are. What does the object do there at time, let's say 3? Let's call this one time 3. Object once more change direction all the way. So the velocity is going to go to the positive because it's moving up now. So the velocity will be somewhere there. And what does the object do? Go all the way to the maximum height again. So here, once more, we have T4, which is the maximum height. Right there, this one is T4, and then the object to go all the way up until it go to the ground once more, which that one would be the case. So this one here is the velocity final reaching the ground after the second bounce. Okay, so this is how this bouncing graph look. Now, something important: all these graphs, all these lines must be parallel. Why? Because they have the same acceleration, which is in this case g. Is constant, and is the gradient of the graph. That one will represent the gradient of the graph. So all those graphs must be exactly the same in terms of they must be a parallel line. Now, if we take down as positive because the object start moving down from 0, is going all the way to the final velocity, which is velocity just before reaching the ground for the first time. what it happened? It changed direction, so it's going to the negative side because we say down is positive. It's going to the negative side, and the object move all the way up, where? Up to the maximum height of the first bounce, but doesn't stop there. It continue moving up until the ground again, which could be, let's say, there. Okay, so that is when it's the ground for the second time. This graph, remember, it must be parallel. That one doesn't look parallel there. Sorry about that. Difficult to draw freehanded. And now there is a change in direction again, and the object once more go all the way and bounces again. I didn't write here T1, T2 because it's exactly the same as the previous one, just it changed the direction of the graph. So in that case, this one will be T1, which was the time took to reach the ground for the first time. Okay, this is a T2, which is, for instance, the time reaching the maximum height. This is a T3, which is the time to okay, let's see the times here because the times is a little bit confusing there. Okay, yes, T2, this is T3 here. T3 was the time to reach the ground for the second time. T4 is at the maximum height for the second time. Okay, but this is the graph, guys. I hope you understand. This one is the most tricky one. I hope you understand. Next time we're going to be doing just a question to practice this graph, and in which one of the question will be only one graph, a single graph, and in the other question we are going to be looking at a bouncing graph. Okay, then after that one we are going to do more questions where we combine everything. We're going to do the experiment to determine the acceleration due to gravity, and we're going to do it using two different methods. Okay, one of them is going to be using a stopwatch, and the other one is going to use the ticket timer. We're going to do both, but now we're going to do, next one will be questions regarding a velocity versus times graph, and then we're going to do the experiments. So thank you for watching. Subscribe for the channel. I'll see you next time. Mr. G here.